Let's begin. Today's January 9th, 2025, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria cards 1, 14, 16, 19, and 20. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, and finally criteria card E. Criteria card A takes a look at our first digit, the triangle digit, and the Turing machine compares it to the number 1. So should the value triangle be equal to 1, or should the value triangle be greater than 1? Criteria card B will take a look at our 3 digits, triangle, square, and circle, and the Turing machine will let us know which one is the absolute smallest. Should triangle be the smallest? Should square be the smallest? Or should circle be the smallest? Criteria card C will take a look at the 3-digit solution, and the Turing machine will let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? Criteria card D will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E again takes a look at our 3-digit solution, except this time it'll let us know a little bit about its structure. Specifically, there are 3 cases. One where the solution may have no repetitions, as in the example 125, or it could be that it's a double number, as in the example 112, or it could be a triple number, a digit repeated 3 times, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 5 criteria cards we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is criteria card C. Okay, so the Turing machine approves of my proposal. Notice that in 314, I do have 2 odds to a single even. And since the Turing machine agrees with that, we can definitely state that there should be less even than odds. So let's go ahead and type that up in our notes in section C, and we'll just simply state that there should be less even than odds. Okay, I think the next thing I'd like to test is criteria card D. Okay, so again, the Turing machine approves of the proposal. Notice that I do have a triangle value of 3 and a square value of 1. If I add those 2 together, I get 4, and 4 is less than 6. And since the Turing machine approves, it must be true that the sum of the first 2 digits should be less than 6. So let's go ahead and type that up in our notes in section D. And we'll say that triangle plus square should be less than 6. And so what can we say about that? Well, I believe that in this case, neither triangle nor square can be 5s, and that's because if I add a 5 even to the smallest of 1, that sum is already equal to 6. And of course, if you pick anything bigger than 1 to add to the 5, that's going to be greater than 6, both of which those are invalid, knowing that the sum should be less than 6. So yeah, we definitely can cross out those 5s. Now, what I forgot to somewhat mention is in criteria card C, knowing that there's a majority of odds, there really are 2 possibilities. Either we're dealing with 2 odds and a single even, or potentially the solution could be all odd. So let's see. Let's go ahead and test criteria card E. Okay, wow. So again, that since my proposal of 314, notice that they are all distinct. It is true, since the Turing machine agrees, that there should be no repetitions. So let's go ahead and type that up in our notes in section E, or sorry, yeah, E. And we'll state that the solution has no repetitions. Okay. Now, as I stated earlier about criteria card C, it's still possible to have an all-odd solution since there is a 5 in circle. Okay. So, yeah, we still, if it's an all-odd, circle could be 5, and then somehow triangle and square would have to split up the 1 and 3. Okay. Well, we are done with this round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice that we didn't test A, comparing that first digit to the number 1, and we also did not test criteria card B, finding out which is the smallest digit. Okay. And we did get 3 checks. So an obvious question is, could our solution actually be 314? Well, as I stated, this is what's interesting to me. We still don't know if it should be an all-odd solution. So what would force it to be an all-odd solution? Well, if that's to occur, it seems to me that triangle, you would want to pinpoint what it is, and that would be a 1. Now, we also have criteria card B letting us know which one would be the smallest. Well, obviously it'd be a 1, and if we were to have an all odd, but again, how's that possible, right? Why would it be all odd? I don't know how you would choose a square value. I guess you would have to, well, if triangle is 1, if you think about it, in conjunction with criteria card D, everything would work for square, right? Because 1 plus 4 is definitely less than 6. So you'd have to pick between 2, 3, and 4, and then circle would be, potentially another odd. So it almost seems that triangle 1 would just produce too many possibilities, being somewhat difficult to pinpoint, especially if it was 1, 3, then how would you pick between 2 and 4? Nothing would be smaller than 1. So obviously you could eliminate the 3 and the 1 as duplicates, but then you would also have 5. And that's if it was 1, 3. What if it was 1, 2? Well, again, how would you pick circle between 3 and 5? 1, 4. That would be the smallest again. So it almost seems to me that triangle cannot be the smallest. So I would almost exclude it from being a 1. So it's not the smallest. That means it could be a 2. Yeah, there seems to be too many possibilities. Well, if it was 4, that forces square to be 1, which would force circle to be either 3 or 5. But again, how would that work? Yeah, that's true. 4, 1. Then you can't pick 3 or 5. So actually, you know what? I'm going to go ahead and cross out the 4. I don't see it as that being a viable candidate, because it would produce 413 or 415, which to me seems to be ambiguous. You cannot tell them apart. Okay. triangle is 1, does that automatically... Yeah, I think you can say that if triangle were 1, this card would be irrelevant. Because this card is telling you there absolutely has to be something small, right? Smaller than the other two. So if you pick triangle 1, there's nothing smaller than 1. So you would know it would have to be. So yeah, I think for that fact, and again, even though I didn't list them out, I think we could say that there'd be probably too many ambiguous solutions with triangle 1, because again, you could do 2, 3, or 4 in square, and again, how would you pick between them? So I guess what I'm saying is that yes, I think we can deduce that triangle should be greater than 1. And we'll just say that yes, we're going to deduce that triangle should be greater than 1. Now that does leave us with 2 and 3 in triangle. If triangle is to be 2 or 3, then we know square can't be 4, because 4 plus even the smallest of 2 would give us a 6. Okay, that does reduce some possibilities. Again, though, I go back to, well, how many odds are there? It's still possible to have 3 odds, but what would force it? Let's see. What if circle were to be the smallest? So if circle's the smallest, a lot of these couldn't happen. So it couldn't be 2, 3, or 4. It would almost force circle to be a 1. And then, now how would you pick between 2 and 3 and 3 and 2? Because it could be 3, 2, 1, or it could be 2, 3, 1. So let's go with 3, 2, 5. Okay. All right, so I guess we've sort of deduced A. So let's just test criteria card B and see if it's true that square should be the smallest. It is not. Oh, wow. Okay, so that did not help. So let's go ahead and say that triangle or circle need to be the smallest. So let's go ahead and say triangle or circle is the smallest. Okay. Well, I definitely did cross out a lot of numbers based on this assumption. So let's go ahead and test A, even though I said I deduced it. So let's see. Okay, so yes, it is true. Triangle is not 1. Okay, so it does approve my triangle value of 3 being greater than 1. So yes, it is true. So this deduction did play out correctly. So we can cross out the 1. So yeah, it would seem then it would be 2, 3, 5. That's if triangle is the smallest. Can we deduce that? Yeah, because I think if we said circle is the smallest, it would make it a 1. Yeah, so I think we can deduce that triangle should be the smallest. Even though it's not 1, it can still be the smallest. So I'm going to cross this out. And I'm going to say that we deduce that triangle is the smallest. And so that would mean that it would have to be a 2. And because well, I guess we could add 2, 1. Yeah, it can be 2, 1 because, again, how would you pick between 3 and 5? You need 2 odds. It can be 2, 2, so it would have to be 2, 3. So square is not 1 or 2. It is a 3. So there's our even. Now we need an odd, but because triangle is the smallest, that means that circle can't be a 1. It's too small. It can't be a 2 because you can't have 2 evens and you can't have a duplicate. Can't have a duplicate 3. You need an odd because you already have an even in triangle. So it can't be a 4. So yeah, so it looks like it's 2, 3, 5. Okay. Well, let's just do a quick review. It was true that triangle should be greater than 1. It is. We deduce that triangle is the smallest. It is. There are more odds than evens. The sum is less than 6. And there are no repetitions. Well, let's go verify 2, 3, 5 as our solution. Well, fantastic. Okay, how do we do versus a Turing machine? Well, it is a 5 criteria card puzzle, and we did exactly 5 tests. In the first round, we did C, D, E, all correct. And in the second round, we did the remaining 2, A and B, where B was the only incorrect. So let's go type that up. So C, D, E, and then A was correct, but B was not. Wow, we tied it. Look at that. I'm a little surprised that, that the Turing machine took only 5. I'm not sure why I'm saying that, but yeah, that's how I feel. But we tied, which is still a win. Well, fantastic. Well, I will say that, again, a little bit of a brain burner. Maybe I over-analyzed, but certain things did pan out where, yes, triangle should have been greater than 1. But it isn't necessarily, since it's not 1, it still turned out to be true that triangle was still the smallest, even though it wasn't 1. Again, one does not preclude the other, right? So, and so, yeah, I think we just got lucky. Well, how about you? How did you solve it? Did you use a different set of criteria cards, and did you discover anything interesting you'd like to share? Add those thoughts to the comments. If you liked the video, please do give it a thumbs up, and don't forget to subscribe. Well, until next time, have a great one.